This video is going to take a look at the 3 new dependency types added in Spry version 1.2.0.513, cone dependencies, offset dependencies, and solid overlap dependencies. Let's start with the source schedule from the demo model that just has a top-down sequence dependency and the simplest source path possible, a wildcard, and allow advance turned on. As you can see, we get the expected dig to the center of the earth behavior that exists because we haven't told Spry that it can't do that. Let's start by enforcing a maximum angle or slope of the high wall by using a cone dependency. The minimum requirements for a cone dependency are that you have centroids in your table and that each process has its centroid field set. With that in mind, let's create a cone dependency and leave everything as the default. It sets a maximum slope of 45 degrees, and you can see that when we rerun the schedule, there is now some enforcement of that rule. Changing the angle, you can see the effect. The Z limit sets how far the cone will look and should be set to something above the height of where you expect the bench above to be. The default of 100 should be suitable for most applications, but it can be reduced, which may improve performance. The same can be said of the radius, which is a maximum as well. Obviously, you can also control the range it applies to, what processes apply, and filter further the tasks that it will apply to. Now that we have a maximum angle enforced, let's add on top of it an offset dependency to create a stagger. As opposed to cone dependencies, which use centroids, offset dependencies use the position indices. So let's say we want a stagger of 4 benches for each strip in one direction, we would write it like this. This says each task in the range is dependent on the task that is 1 strip index down and 4 bench indices up. If you wanted to enforce this in both directions, you can add a comma, and if you want to ignore the effect of a certain level, such as seam, you can replace it with a wildcard. If we wanted to, we could also add in a third dimension to our stagger by staggering our block direction as well. The final new dependency type is solid overlap. The way this works is that it looks at your solids from above, below, or both, and applies a dependency based on how much of the solid needs to be completed before releasing the next task. An example in the demo model is how we can use it to make sure that you can't dump in pit until the related source solid is completely depleted. In this case, we'll set it to 0%, which means the solid has to be completely free and clear before the task is released. You can expand the boundary and make it look even further away from the solid if necessary. It's important to note that solid overlap dependencies are computationally complex, so if you can create a different type of dependency that suits your needs, it will probably run faster. If you're on top of your grouping expressions, you can ensure that only the tasks you want interacting with each other are in their own group, otherwise just leave them as the default. Thank you for watching, and as always, if you have any questions, please contact the Precision Mining team by email on support@precisionmining.com or calling us on 07